Good afternoon. Welcome to another edition of Backyard Chemistry from Soda Center Field. It's been a while, we apologize, but we're back in business for a daytime edition. Today, no explosions, no fires, but we are going to explore the relative activity of three metals. What are the metals, you ask? I'm so glad you asked. They are copper. You probably recognize the shiny color of copper. The other one is a strip of zinc metal. The third one is embodied within the silver nitrate. So it's silver metal, zinc metal, and copper metal. So what we're going to do is compare two metals at a time, a kind of contest, see which one is able to reduce the other, and declare a winner as to activity. So the first question we're going to answer is, what is more active, copper or silver? Okay? Copper or silver? All right. So what we're going to do is put the copper metal into the test tube, and we're going to pour in some 10th molar silver nitrate. Now I have my gloves on because, as you all know, silver nitrate will stain the skin by reduction. So let's see if I've got enough to completely cover the copper helix. Let's see what we've got. All right, there it goes, there it goes. Oop, I'll leave a little bit at the top. All right, so we're looking for any evidence of chemical change. Any evidence of chemical change. Okay, now just let that sit. Okay, now we're going to compare two other metals here. Those metals are zinc and copper, which is present in the copper sulfate. So I've got a beaker, tall form beaker, and I've got the zinc metal. And I'm going to cover the zinc metal mostly with 10th molar, actually it's just aqueous copper sulfate solution. So let's go ahead and pour that in and see what happens. I'm going to pour it to just about the, whoa, that's enough. Looks like we had a little residue down there. Now, I think we're already seeing evidence of chemical change, but it's going to take some time. So what we're going to have to do is let this sit, and then we're going to come back in part two, and I'm going to do a little explaining as to what did or did not happen, and let's see if we can arrange the three metals, silver, copper, and zinc, in order of their relative reactivity. Which one is mostly reactive, least reactive, and which one in the middle? So will you join us for part two? Thanks, I knew you would. See you soon. Welcome back. Part two to our experiment comparing the activity of metals. If you recall, we had copper metal dipped into a solution of copper sulfate. We had a zinc strip into the copper sulfate. And now we're going to look at the results. Wow, do we have some results? Let's see if I can pull this helix out without disturbing, or maybe we can just get a focus on that. Can we, our assistant there? Yeah, look at that. That has really and truly, two things have happened. Number one, the copper metal covered with the silver nitrate. I think I said copper sulfate before, I was in error. The silver nitrate and copper metal. We were comparing copper and silver. We have a clear winner. We have enough information now. Look, the copper metal is coated with whiskers of silver metal. Totally obscured. You can't even see the copper helix because of all the silver metal that is plated out onto the copper. Number two, the formerly clear silver nitrate solution is now bluish. That tells us that the copper has given up its ions, its electrons, to reduce the silver metal, to reduce silver ions. So we have demonstrated without a doubt that copper is able to reduce silver ions to make silver metal. From what do we conclude from that? silver is less active than copper, or is it the other way around? Copper is more active than silver because the copper has given up its electrons preferentially to the silver ions. Otherwise, we would have no reaction. So there we have the first of our mystery. Copper is more active than silver. Now, next, what about the competition between zinc metal? Let me hold this up a little bit. Remember, we had zinc strip into the copper sulfate. I'm going to take out the zinc strip. Ooh, what have we here? That does not look like zinc anymore. What does that side look like? Yeah, let me turn it around here. It's the same on both sides. Oh boy. Look at that. What do you think that metal looks like? Doesn't look like zinc anymore, does it? It looks kind of reddish. It almost looks like copper metal. Indeed it is. It's the same copper metal I hold in my right hand here. So what have we demonstrated? The zinc is giving up its electrons preferentially to the copper ions. So zinc is more active than copper. So what have we got here? We've got enough information to put the three metals in order of relative reactivity. Zinc was more active than copper. Copper was more active than silver. So we're going to put zinc at the very top of the scale. We're going to put copper in the middle. Zinc was more active than copper. And then poor old silver, way down at the bottom, the least active of the three. Zinc, more easily oxidized than copper. Copper, more easily oxidized than silver. So there you have it. We have established a miniature series of activity of the metals, three metals. And quite dramatically, I might add. Take a look at that copper. That is stunning. Take a look at those whiskers one more time. Look at that silver metal. In fact, let's see if I can pull that out. What often happens is the whiskers just keep falling right off. Oh my goodness gracious. Look at that. You really cannot recognize the color of the copper anymore. It's covered completely with the silver metal. And there we go. Notice that this is now blue. It started out colorless. That's because copper has formed copper ions. And the copper metal is starting to disappear a little bit, as you expect. So we'll go back in there. There you have it, the activity series of copper versus zinc versus silver. Who was one last time winner and still champion? Zinc. Number 2, the copper. Number 3, the silver. Activity series of metals. Thank you for joining us on another episode of Backyard Chemistry. Stay tuned, subscribe, thumbs up if you like it. Come back and see us again. Another example of chemistry for today's world.
Backyard Chemistry! Bye-bye!